So what if you've got something a little more involved than a single unit? So for instance, let's say you've got to convert, say, 5.8 inches per hour. That is a speed. Maybe you've got a snail, right, that's going at 5.8 inches per hour, and you want to calculate its speed in maybe centimeters per second. Right, because maybe the record books list the top speed of a snail in centimeters per second, but you measured it in inches per hour. So how would you do something like that? So I think the very first thing you need to probably do is you need to rewrite the inches per hour like so. So you need to clearly show what's on the top and what's on the bottom of a fraction. And then you're going to multiply by a conversion factor. Now, inches to centimeters we've seen before. All of these conversion factors I'll give you on the exam, although you will probably just sort of remember some of them from using them all the time. And we can also know the relationship between hours and seconds, because we know 1 hour is always equal to 60 minutes, and 1 minute is always equal to 60 seconds. So that's actually kind of a lot of conversions here, isn't it? So now we get to pick. Do you want to convert your inches first or your hours first? And it doesn't really matter. We can go ahead and we can go with inches. So we just take the 1 inch per 2.54 centimeters. And all I'm going to do is I'm going to copy and take the inch. And do I want it on the top or the bottom? And I actually want it on the bottom, don't I? Because I need those units to cancel. And the 2.54 centimeters, right, I need to put on the top. And the reason for that is that if I look now, my inches cancel out, and at this point here I would have centimeters on the top and hours on the bottom. So I got to do a couple more conversions, and I won't go ahead and cut these out because I want to actually write them in a different color. But I need to convert my hours to seconds. Now I can get my hours to minutes, and if I've got the hour, obviously it would need to be on the top to cancel out. So although there are two conversion factors, you don't have to write them. And the 60 minutes goes on the opposing side, so they can't both go on the same side. So I'm going to cancel my hours. What would that leave me? That would leave me centimeters on the top and minutes on the bottom. That would be centimeters per minute, but I need centimeters per second. So I do one more conversion, and the one more conversion is to take minutes into seconds. So at the bottom of the screen here, a minute, 60 seconds. So what do I want to do? I want to get rid of the minutes, and so I need to put the minutes in such a way that the minutes will cancel, and I want to leave behind seconds, so I'm going to write the 60 seconds on the bottom. And what do we have here? We got centimeters all alone on the top, so all the other units have canceled, and we're left with centimeters on the top, and everything on the bottom is canceled but seconds. So I'm going to go ahead and just write that down now. So let me switch to black, and that would be and the units are centimeters over seconds. And then I just need my calculator. So on your calculator, I'm going to reach for my calculator, sorry for that, and I'm going to go ahead and type this stuff in. So there's a couple of ways to do it. I'm going to type 5.8, and I'm going to multiply by 2.54, and I'm going to punch equals, and then I'm going to divide all of that by 60 times by 60. So I'm going to hit divide, and then I'm going to put parentheses and write 60 times 60, and that keeps me safe. So there's a danger if you type too much stuff on your calculator at one time, it can get confused, and so you got to use parentheses for say everything on the bottom and everything on the top, and just divide top by bottom. And it's a pretty small number, so 0.00. Okay, so no significant figures yet. So leading zeros are never significant. How many do I have? 5.8 has 2 significant figures, and everything else is exact. So all of these down here are an infinite number of sig figs. So if I'm multiplying or dividing, then I go by the worst number. So 2 would be my worst. So 0.00, nothing there. And then I've got, I'll just scribble it out here, 0.00409 and a whole bunch of 2s. So those don't count. The 4 counts, the 0 counts, the 9, well, I'd love to count it, but I can't, right? So that would be 3 sig figs if I counted it. So I get rid of that, and then I got to do some rounding up here. So that 0 becomes a 1, so 0.0041 centimeters per second to 2 significant figures, and that's the answer. Okay, here's one for you. So maybe you've got to convert 55 miles per hour to, gosh, I don't know, yards per minute. Okay, and I'm going to tell you that 1 mile is 1,760 yards exactly, and 1 hour is exactly 60 minutes. So go ahead and pause the video here and try this conversion, and then unpause me here in a couple of minutes and let's compare notes. Okay, I'm back. So how would you set this up? So I think probably the thing that catches people the most is when it's miles per hour, you got to remember to write miles on the top and hours on the bottom. And because you're multiplying and dividing, the order you do it in doesn't matter. So I'm going to convert my hours first, and I'm going to put my hour on the top and my minutes on the bottom. And that causes the hours to cancel out. So now I got miles per minute. And I'm almost there. I need it in yards per minute. So I got one more conversion. Because I got miles on the top, I need to get miles on the bottom. So that 1 mile goes on the bottom. The 1,760 yards goes on the top. And I should just go ahead and cancel those. So there's the miles gone. So what do we have? We have yards per minute. So yards per minute here. And that has 2 significant figures. So at the end of the day, we can only write the first 2 digits that aren't a 0. And if I got my calculator, and here it is right here. Okay, 55 times 1,760 divided by 60, all the ones I can pretty much ignore. I get 1613.33333 recurring. So this would be 16. The 1 I get to remove. I can just kind of scratch it off there. But because I need the 1 to be in the thousands and the 6 to be in the hundreds, I've got to go ahead and pad it up, right? I got to put those zeros in place because my calculator is reading this. But I gotta keep the 1 in the thousands and the 6 in the tens, or the hundreds, sorry, and the 1 in the tens I get rid of, and the 3 in the ones, and everything else goes away. So I gotta make sure I pad it up with zeros. Or if you were extra smarty pants, right, you could write that as 1.6 times 10 to the 3 yards per minute. You could also go ahead and show off and say 10 to the 3 is the SI prefix kilo. So you could write 1.6 kiloyards per minute. Although that's pretty darn nerdy. If you did that, you're a giant chemistry nerd. That's okay. Well done. Let's apply this maybe to a dosage calculation. So perhaps you've got a magic medication, okay, whatever it may be, and 3.6 milligrams is a perfect amount to give a 175-pound individual. And so this is the drug, and this is the person. And perhaps you want to know, right? You want to know if I've got a 197-pound individual. The question is, how many milligrams of the drug should we give them? So this is a perfect case where you can do this using conversion factors. So 197 pounds, I need to convert to milligrams of drug. And really, you just have to take the top things here, right? The milligrams of drug and the pounds of person, and put one on one side and one on the other. So they're both masses, but one's the person and one's the drug. So be careful there. So I need to put the pounds on the bottom, 175 pounds. And I put the 3.6 milligrams of drug on the top. And I can go ahead and run that through my calculator. So I just made those numbers up, actually, so I don't have it pre-calculated. So 197 times by 3.6 divided by 175 is 4.05, blah, 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 blah. So to 2 significant figures, that would be 4.1 milligrams of the drug. So I can do a dosage calculation if I want to this way. I just want to show you one more little trick, actually. So I forgot to mention this earlier, but sometimes it's kind of annoying to write this out using multiplications and divisions. And so you can use what's called the train track method. So literally you can just take a set of train tracks. Well, okay, it's not really train tracks, but that's what we call it. Or that's what I call it. And you just kind of write the things that you multiply on the top and the things you divide on the bottom. And it's very, very nice because then it just takes up a lot less room. And so you could rewrite it something like so. And if you've got multiple conversions, so if you wanted to do that, I don't know, that 55, miles per hour to meters per second, let's say, you could train track this out. So you would take 55 miles per hour. Okay, and then I'm going to set my train tracks up, and what do we know? We know that 1 mile is something like 1,600 meters, and 1 hour is 3,600 seconds. I'm just kind of pulling that out of my head, actually. And so you can set it up train tracks. So now the miles cancel, the hours cancel, and you're left with meters per second. So that was what we wanted to do. So meters per second. But notice those train tracks have really squished this problem down, right? I was able to fit it in practically in a margin. And if I take 55 times 1600 divided by 3600, it is 24 to two significant figures meters per second. So if you like train tracks, choo-choo, right, this is another really good way to set up the problems. Congratulations, you are now a conversion wizard.